Hello and welcome back. Today we're going to talk about what exactly is computer science. You heard the term, but maybe you're not quite sure what is it. Today we're going to get into this. So here's a very informal definition. Don't write this down in the exams or anything of the sort, but basically the study of computational systems. You can Google it up. There's different definitions. No one exactly says the same, but basically it's everything that has to do with computers and basically with using them in our case. So not only using them ourselves, but also making them usable. For example, if you have an operating system like Windows, this is something that makes it usable and that we do in computer science. Maybe one important distinction is that we do not build the computers usually, and this is the engineering side of it. You can still go into this, but it's not the main focus of the computer science, right? We have to look at it to see what can the computers do, how do they work, but it's not our main focus in the end. So then we have the big notion of programming. What exactly is this? Basically, we have three big things here. So we have computer programs. This is what we program in the end. And they interact with two things usually. You have data stored in your computer and you have data in the memory of your computer, right? If you don't know what's the difference between this, make sure to Google this now and really understand what is the difference, because this is the key foundation of being able to program. And so basically what we want to do is switch data from being stored into our memory. So in the memory, we can access it from our program. And this is done by our computer program. And basically you can call this the data retrieval and data storing. So why do we need to do this? As we said before, if the data is stored on our device, we can keep it. So we can power it off and it's going to stay there. But to interact with the data, especially interact with it in an efficient way, we have to have it in memory. So we have to retrieve it from the storage, load it into memory, then do something with it and go on. And this is basically what we're doing here. So our computer program is always accessing this data memory, and here we basically do the manipulation. So for example, if you have a text file on your computer, just a Word file for example, you have it stored, you load it into memory, you change some text, and then what you want to do, you want to store it again. And this is basically what your program does whenever you're writing something new to your program or writing something new to your Word document. Now, one important aspect is how this data is represented in a computer. Maybe most of you already know. The computer doesn't understand our language. It's just a bunch of ones and zeros in the end. So basically on or off, yes or no, however you want to call it. Maybe you know this from Tinder, right? You can just swipe right or left. Maybe nowadays it has more function, but this is the idea of it. But something more accurate would be a power switch. So this is also how it's done in computers. Basically, you have just very low power flows that are a bit higher or a bit lower, and these basically can be a bit higher or a bit lower, and the higher could be the 1 and the lower could be the 0. You can also switch it, so higher could be the 0 and lower could be the 1, right? So it doesn't really matter, you just need to have two states. And then what does the computer do? Basically, you can see here, it's called a logic gate. So all the computer does is take A and B. This would be each would be a 1 or a 0. So A is a 0 or 1 and B is a 0 or 1. And then it's gonna take this in and put something out, the Y in this case. And this is also gonna be a 1 or a 0. You can read up on this, it's called logic gates, and basically everything in your computer is working like this. So you put in two electricities, you give one out, and then there's different basically gates, so different options what you give out. But this is the whole magic of computers in the end. And now, how do we make this data understandable? Because right, you don't want to look at your computer and you just see a bunch of ones and zeros, and then you're just going to ask yourself like, what the heck? What even is this? And you're going to try to understand this, and then at some point you're like, yeah, who designed this? This makes no sense at all. and you're just fed up, and then you're going to call the university and you're going to say, yeah, no, this program isn't for me, I want to quit. And so people thought about what we can do to avoid this. And basically the answer is standards. So we need to have some rules in place that we can actually use. And the rules in this case, they're not like with medicine that you need to wear your gloves, but instead we have definitions of how we represent things. So for example, this is the ASCII code table, and here we just defined from 0 to 255, every number gets a character. So for example, if you have number 56, it's going to be a big A. Or if you have 6, then it's going to be the acknowledgement. And with this, now how this works in a computer is that you take a bunch of ones and zeros, and this bunch of ones and zeros, you're just going to define if it's all zeros, this would be the 0, 0, so the null character. And you can say if you have 5 zeros and 6 ones, this would be the 0, 6, the acknowledgement. And so you just define which sequence of 0 and 1s is going to refer to which character. And then you can just store the sequences as zeros and 1s, right? And then you can do some program that's going to see, okay, this would be an A, this would be a B, this would be a W, I don't know what. And this is basically how the computers work. Now, important, this is not unique. So there's not just this ASCII code table. This is actually very old and not always used anymore. Still used, but not always. Mostly not, I think. And basically there's different standards nowadays, and yeah, read up on it. I think the most used is UTF, it's called, and there's different versions of it. Maybe it's also UFT, I'm not quite sure. And very important, if you're working with computers, try to break everything down, right? So there's this quote citation by Arthur C. Clarke, or this quote, and it's basically what he said: any sufficiently advanced technology is indistinguishable from magic. And really think about it. For example, if you see someone on his computer screen and is playing a video game, how is this even possible, right? It seems natural to us because we were born with it, but for people who didn't have this before, just think about. You see someone looking at a screen, the screen is moving around like if you're watching out of a window in a movie, and then you're just gonna press some random buttons and move this thing around, and you're actually gonna move on the computer. It seems natural to us, but it's a huge step basically. And always remember, Rome was not built in one day, and neither is today's technology. So we started out with like just a screen that could give you something, and you could just click on it, and you had text files, and that was about it. You could store like one crappy image or like 10 crappy images. And today we have a lot of space to store hundreds of high resolution images and everything, right? But think about how this all came to be, right? And these computer games that we have today, they didn't just pop out of nothing. They weren't built from zero, but instead, over time, we built technologies, we learned stuff from it, we advanced it, and so on. And so when you do this, try to break it down step by step. So for example, if you have this computer game, which is, I think it's Counter-Strike Source, always remember there was a Counter-Strike game before this, and this game was made as a mod from another game. So always try to track back the history, see how it goes, and then think about how could it be done on a low level. So for example, this game, how can I animate this? So basically it's just, I see this in front of me, I see this other in front of me. If I press a key, this is going to happen, and so on. So just try to understand how these applications work. You can also ask, Google it, ask an AI or something, but try to understand how it works on a lower level. And so what I think is really important in computer science is that you care about the whole forest of things. So basically, the forest is the big concepts, right? So in a forest, you have trees that grow together and work together. You have different layers of forest that, support each other, animals that support each other. And I think it's the same in programming, right? You have different languages, you have things interacting, you have your storage, you have your parts in the computer that execute your code, the things that store the code, and so on. And so it's really important to get your head around what is there and how it's working together and why we're using it. But you should also have a look at the individual things, right? So just one programming language, really learn about this. Still, a programming language can be a huge tree and you don't see everything. It has roots, it has an internal structure, it has ideas and everything. So really dive into it, but also look at the broad concepts, right? So really care about the broad concepts, but also care about the individual theoretical things, like Python, for example. And then basically we have theory versus practicality or practical. And basically there's two things. So if you're just going to do practical work, then you're mostly going to be a programmer, software engineer, and you're going to do some applications, operating systems, or something else. And I think most programmers use, or most computer science students go into this area. But there's also the theoretical part of computer science. So if you're really into this math things and you like to prove stuff, don't miss out on this. There's a lot of things that you can do, a lot of algorithms that you can look at, and so on. So really cool stuff. And don't forget, you can also have the team aspects. So especially in computer science, they're often regarded as not being social and so on, blah, blah, blah. But especially if you're working as a software engineer, for example, it's really important that you have team skills and soft skills as well. And a lot of companies, they really look at this more than they look at your skills as a programmer in the end. Both are important, but don't underestimate the stuff that you can learn about friendship, community, and teamwork. And the university is a great place for this, so make some friends as well, learn to work together, and try to study together as well. And this would be the end of it. I hope you could learn something. And yeah, thanks to all the cool people for the images that we can use. And yeah, see you all in the next one.